Hello everyone, welcome to Global Azure Conference. Today we are going to see how to build a secretless application in a serverless environment. Myself Divaka Kumar, I work as a senior software engineer at H&M. So this is going to be our agenda for the next 30 minutes. So we are going to see how we evolved in terms of secrets within our applications or managing the secrets in the Azure portal as well. And we are going to cover what are the best practices that we could follow in order to avoid different trade-offs, and we are going to see a demo out of it. And at the end, if there are any questions, I will try to answer those questions after my session. So in the early days, we used to store the secrets or the configuration in as part of the settings file. And the drawback of this approach is it is straightforward. These secrets are in the plain text format, and once you commit these changes, it gets inside the source control, and that is where there is a possibility of leakage of these secrets to other team members or the other teams. And then we started using different ways in order to get rid out of it. So few of them are like using the user secrets that comes along with the .NET SDK. So this comes along with the .NET SDK, which you could use, which will basically create a local profile in your system, and you will be able to store the secrets as part of those local profile. Or else you will be able to create an environment variable, which also doesn't get into the source control whenever you push some changes. Or else there is another way, like where you will be creating a local.settings file, so which will be by default will be ignored by the GitHub. So inside the Git node, like you will be having this file, so that like it won't get inside your source control. So these are different ways we have used in the early days, like in order to so that like the secrets are not getting into the source control. But the problem of this approach is it doesn't scale with the large teams, because now if a new team member is going to join, and you need to share these credentials, it can be any connection strings that you are having as part of your local profile. You need to share them these details, and they need to have these details as part of the local profile. And then we made use of the Azure Key Vault, which is the best way to store the secrets or the sensitive informations. And this approach is the best way, even in the recent days. But the drawback of this is if you want to follow the cryptographic best principles, right? Like any secrets that is beyond a specific timeline, you need to rotate those keys in order to make sure you are following a best practices. And now comes the additional overhead to the development team. You need to manage these things, and you need to rotate these keys in a periodic manner whenever a specific key is going to expire. And that is where the managed identity comes into the picture. So managed identity provides you a seamless way of authenticating or authorizing a particular resource access. And whenever you think of an resource that is able to communicate with an Azure AD, you will be able to create a service principal using the managed identities. And with the help of managed identities, you don't need to store these secrets as part of your local profile or as part of your settings. And also you don't need to manage these rotation of secrets as well. So everything is managed seamlessly using the managed identities. So let's see like how we can make use of these managed identities in the serverless environment. So before getting into the managed identities, like how it works behind the scenes, let's see like what are the different types of managed identities we have. So we have two types of managed identities. One is the system assigned managed identities, and the another one is the user assigned managed identity. So if you consider any Azure resource, So consider this is going to be an Azure function. Okay. So here you will be able to assign this Azure function with an system assign manage identity or else an user assign manage identity. So when you would choose one over the other. So the system assign manage identity will be tied in a one-to-one mapping along with this function app. So once you delete this function app, the system manage identity will be going along with it. And in case of user assigned managed identity, you will be creating an identity. You will be creating an identity which can be used for this function app, and also it can be reused for another resources as well. So if this would be the common scenario where most of the developers might be facing, because you need to create one identity and you need to provide them with an access, specific access, or a rollback access control permission to grant certain specific resources. So you will be able to do that with the help of user assigned managed identity. So now you don't need to recreate these identities as part of different resources. You will be having one centralized user assigned managed identity, and you will be making use of it across different Azure resources. And when you want to have a strict communication between the managed identity and the Azure resources, you will be able to do that using the system assigned managed identity. Because once you delete that particular Azure resource, the service principal that you create out of the managed identity will be deleted automatically behind the scenes. The way to configure these things in Azure portal, we will be seeing them in the demo, but just to give an overview about it. So under each Azure resources, like you will be able to find an identity in the settings option. So under the identity, as I said earlier, you will be able to define two different managed identities. One is the system assign, or another one is the user assign. So the system assigned managed identity is the one that gets tied along with this particular Azure function app. So now let's see like how it works behind the scenes. So if you are familiar with creating an application using the Azure AD, so you might have understood like once you create an application, or once you register an application as an enterprise or a normal application, you will be generated with an object ID, which is nothing but a service principal ID, which is an unique identifier across that particular tenant. So that is the same case in the managed identity as well. So there will be a resource provider which will issue a certificate, or it can be referred to as a service principal. This is the unique identifier for that particular tenant. So now this service principal is being issued to a IMDS system. So what this system does is it interacts with the Azure AD. So this is going to be your Azure AD, and now it uses the service principal that is generated by this resource provider, and it gets the token from the AD with the help of the service principal. And we will be getting an access token in return, and this access token will be having required permissions that you already configured along with the service principal in order to access different resources. So this is how the managed entities works behind the scenes. So it is similar to our AD registering an application. So here there will be a managed identity resource provider which will be creating a service principal ID for your a resource, and it will be used by your IMDA system to get an access token from the Azure AD. And now this access token will be having certain permissions or certain roles that you have defined along with the service principal to access the Cosmos DB or any other Azure resources that are already communicating with the Azure AD. So now I'm gonna take an example, an application that I have developed known as Cosmos Spark. It is generally an chat application that you could see here. So this application is comprises of different Azure resources that you could think of, right from the Azure Cosmos DB, Azure Functions, and Azure Maps. Every Azure resources are being used by this application, and it is entirely based out of the serverless architecture. So now within my application, I don't have any single secret along with my source code. So entire thing is handled in a different way, and we are gonna learn how to do that. So I'm just gonna take a single use case out of it. So obviously, in my chat application, I have used a change feed, which is nothing but a Cosmos DB trigger, an Azure function. So in this Azure function, what I did is I have created a system assigned managed identity. So now I will be having an service principal, which is an identifier for this resource. And the way how I make sure that none of the secrets are inside my source control is I made use of two Azure resources. One is the Azure app configuration, and another one is the Azure Key Vault. There could be many reasons where you want to store different sensitive information. That doesn't mean it should be a connection string or anything that is related to the Azure services. It could be a different one, like maybe in my application I have used map API key. So you won't be able to use managed identity in that case. You need to use a different way in order to store those sensitive information in a secure place. So that is where I have used Azure Key Vault. And Azure app configuration I have used in order to store different configurations with respect to my particular application. And also, whenever I want to interact with the Azure Key Vault, I don't go directly from my Azure functions to the Key Vault. In turn, what I did is I communicate always with the Azure app configuration, and inside this app configuration, I used to communicate with this Key Vault using the Key Vault reference. So with this Key Vault reference, I will be able to fetch the secrets in my applications. So with this system assigned managed entities, there are certain roles that I have allocated to these service principal. One of them is like the app configuration data reader, by which I will be able to communicate with this app configuration. And the another one is the secret permission access policy. Like I need to add access policy for this service principal in order to access these secrets inside the keyboard, in case if you want to directly communicate with this keyword. And the another one is I have made use of the Cosmos DB built-in data contributor in order to access the different documents within the Cosmos DB collections. Read and write operations. To perform read and write operations within a particular container, I have used this Cosmos DB built-in data contributor role. So all these roles are being allocated to this particular service principal ID. And the way you could interact the between the Azure app configuration and the keyword is using this system assigned managed identity that I tied within the app configuration. So now this app configuration will be having a role in order to access the keyword. So in that case, I don't even need this Azure keyword role inside my Azure functions. So I can directly communicate with the Azure app configuration to get the secrets. So how I configure all these things, maybe I can show it in the code. So this is the change feed trigger that I was telling you. Maybe I can use these. So now if you look into my app settings, I don't have any configurations or any sensitive information as part of this app settings. All I have is the app configuration UI. So with this URI, I will be able to get the normal configurations and as well the sensitive information that are stored in the Azure keyword. And the way how I interact with this app configuration is using the manage identity. So in order to do that, so you need to have this extension, the Azure App Configuration, with which you will be able to bind certain configurations in your iConfiguration method. So here, what I specified is I need to connect with my app configuration URI that is going to be my Azure App Configuration. And if it is going to be the development environment, what I have done is I have chosen a Visual Studio tenant ID that is tied with this Visual Studio code. The reason why I did this is there could be multiple tenants that you have signed in along with your particular IDE. And if you want to specify a particular tenant ID where you have allocated a specific role, you need to mention this Visual Studio tenant ID and you will be able to provide that particular tenant ID. And if you are using this default Azure credential options, then it will look for certain precedents, it will look for the environment variables, and then like it will look for managed identities that is tied up within this resource, or else it will look for the Visual Studio tenants as well. So in our case, if it is going to be the development environment, it will look for this Visual Studio tenant ID, and it will look for the specific roles that has been assigned to this tenant. Or else, if you have deployed this application into the Azure environment, then it will make use of this default Azure credential options, which will basically point to a service principal ID that is created by your system assigned manager identity. And here, what I did is I have configured the key vault along with this Azure app configuration. So this also authenticate using the same mechanism as I did for the app configuration. Here also you will be making use of the default Azure credential options, and you will be able to communicate to the key vault in order to get the secrets, and also you will be able to communicate with the Azure app configuration in order to get the configurations. Going back to the slide. So this is the precedence that I told earlier. The default Azure credential options will look for these precedents. So it will first look for environment credential, like if you have stored any client ID and client secret along with your app settings, then it will look for it. But in our case, we don't want to maintain any secrets as part of our local settings or in the app settings as well. So that is where like we made use of this manage identity credential in case of the Azure deployed resources, and the Visual Studio credential will be used for our local development purpose. So that is how the secrets are maintained in the Azure keywords, and as well like as part of the source code, I haven't maintained any secrets. So when it comes to the Cosmos DB, that's quite different because there was a new support that has been provided with respect to the Azure functions, where you will be able to make use of this managed identity in order to communicate with the Cosmos DB. Earlier, we didn't had this capability. The only way that we could communicate with this Cosmos DB was using the connection string, and we need to explicitly mention this connection string either in the app settings or in the Azure Functions settings. As part of the Azure Functions configuration, you need to mention this connection string, and you need to again work on those secret rotations or the key maintenance as part of this strategy. But recently, there was a public preview has been released for this Cosmos DB extension, where you can make use of this managed identities as well. The only difference that you could see in the earlier, like if you are familiar with the earlier Cosmos DB trigger, you would have seen in this particular parameter, it would be a connection string, but now it is a connection. So this, what this means is it is just a name to that particular manager entity that we give. So in this case, like it can be a Cosmos DB connection setting or any name that you can provide here. And we need to configure these settings in the deployment in the app settings or in the Azure functions, where you just need to mention the URI of that particular Cosmos DB and also which way you need to communicate it with. So in order to do that, these are the specific properties that you need to mention along with your app settings. You need to mention your connection name prefix. In our case, it is going to be the connection DB connection settings underscore underscore the credential. So the value of this is to be mapped with the manager entity. Now we say the Azure in order to use manager entity in order to authenticate whatever the resource, the access that you want to have with the Cosmos DB. And there is another property that you need to add as part of the app settings or the Azure Functions configuration. That is the connection name prefix along with your account endpoint. This account endpoint is nothing but your Cosmos DB URI. So now, by making use of this managed entity, we didn't store any connection string as part of the app settings. We just mention which way we need to authenticate. We just mention a managed entity should be the way, and also we just mention which account endpoint we need to point to. That is going to be our Cosmos DB URI. And the next thing that we need to do is we need to allocate specific roles to this particular service principal ID in order to communicate with the Cosmos DB, either perform read or write operations. And these are two built-in role definitions that are provided within the Cosmos DB. So with respect to the Cosmos DB alone, it is not straightforward. You wouldn't be able to assign these permissions in the Azure portal itself in the data plane. You need to assign these built-in role. Either you need to create a new custom role out of it, or else you need to specify this built-in role along with your Azure CLI. So in your CLI, what you need to do is you need to mention your resource group name, and you need to mention your account name, that is going to be the Cosmos account, and you need to mention your role definition ID. It can be either the read role or it can be the read and write role. In our use case, we have used Cosmos DB built-in data contributor, and that should go here. And with in the principal ID, this is where you will be mentioning your service principal ID or the manager ID that you create as part of your Azure portal. So you will be mapping that here. And when you execute this command, Cosmos DB SQL role assignment, so what it happens is like you are allowing this data contributor role for this particular service principal. And that is how, whenever this Cosmos DB trigger has been deployed to the Azure, it will be making use of the managed identity, because now we have asked Azure to make use of the managed identity in order to authenticate. And once it gets the access token, it will be looking for the roles. And now it has the data contributor role attached to it. And that is how it will be able to read and write a specific data from the Cosmos DB. So let me show you how it is configured here. So as I said earlier, as part of the local dot settings or in the, maybe I can show in the portal. So this is the change fee that I was talking about. So in the first place, you need to go to the identity, and you need to generate and system manage identity for this particular resource. You will be getting an service principal identity. And the next thing that you need to do is you need to open the CLI, and you need to bind that particular data contributor role to this particular principal ID. So now that this has been done, the next thing that you need to do is you need to go into the configuration. And as part of the configuration, now you need to have two properties. One is the connection, then the managed identity name that you have used in the place of connection. So in the place of connection, I have used Cosmic DB identity. So that should be the exact name that you should use in the configuration as well, followed by the account endpoint or the credential. So the value would be, for the credential, it would be the managed identity. So now we ask Azure to authenticate this call with the managed identity and get the access token, which will be basically having the built-in data contributor role that we have assigned in the Azure CLI. And we are also pointing to which Cosmos DB account that we need to interact with. And this is the extra thing that you need to do as part of the Cosmos DB connection, or the Azure Functions Cosmos DB extension, which was released recently. But if you think of any Azure resources, or even whatever the application that you create using the Azure AD, you can very well make use of this managed identity in order to assign them with a specific role, and then you will be able to seamlessly authenticate without you even having these secrets configured inside your app settings, or you need to maintain these secrets rotations. So everything will be handled by the managed identities. So that's all I had for today's demo. So if you have any questions, maybe you can leave a ping in the YouTube chat so that I can get back to you if there are any questions. Thank you.